Welcome back. This is Ganitika.com, a website for mathematics lovers, learners, and leaders. And today I'm going to give you the mistakes that you might be making with derivative rules and how to overcome them. After watching this video, you will never ever make these mistakes in your examination. So are you ready? Before we continue with this video, you should have learnt these rules: power rule, product rule, quotient rule, chain rule, and also derivative of trigonometric and inverse trigonometric function. If you have learned these topics and you need a quick review on these topics, you can get into the calculus playlist, under which you have lots of shorts on these rules, a quick review on these rules, so that it will be very helpful for you to proceed with this video. And if you like my videos, please subscribe to this YouTube channel and like and share my videos with your friends and families. Apart from these rules, you should have also learned how to find the derivative of exponential and logarithmic functions and how to differentiate implicit functions. If you do not know any of these things, you have everything under the chapter Calculus in the website Ganitika.com. You can go to the Content tab, and under the Content tab, you can go into the Calculus chapter and you can see all these rules explained clearly with videos and examples. At the end of this chapter, you have the formulas for derivatives of all the functions. So let's proceed with this video. The first example is find the derivative of y is equal to 2 to the power of x. Pause the video here, try to find the derivative of 2 to the power of x, and then continue with this video. So you must have used power rule for this because it's 2 to the power of x. Therefore, using power rule, you should have answered this question as dy dx is equal to x times 2 to the power of x minus 1. Yes? Did you answer like this? Then you are wrong, because we cannot use power rule for this. For power rule, the base should be a variable and the power should be a real number. Is this the case here? No, in this case, the base is a constant and the power is a variable. So wrongo, you are wrong. So this is not right. You cannot use power rule for this function. So what else can I use? Wrongo is asking you. And you know that 2 to the power of x is an exponential function, wrongo, right? And righto comes here to help you out. From the formula, you know that derivative of a to the power of x is a to the power of x ln of a, logarithm of a to base e. So a to the power of x ln a. You can see that 2 power x is same as a to the power of x, a is equal to 2. Use this formula, wrongo, righto says. And using this formula, wrongo answers the question correctly. 2 to the power of x ln of 2 is the answer for the derivative of 2 to the power of x. Very good. Let's continue with the next example. Example number 2. Are you ready? Find the derivative of e square root of x. E square times square root of x. So pause the video. Find the answer for this. Are you ready? So obviously, because it is e square times square root of x, you should have used product rule here. U is equal to e square, v is equal to root x, and the derivative of u is 0. Derivative of root x is 1 over 2 root x. Come on, here wrongo is having some doubts. U is a constant and you have a derivative of 0. I'm going to substitute this in the formula. Is this correct? He has his own doubts. Yes, there is 0 in the formula. You are going to substitute that. You are going to simplify this as e square over 2 root x. Is this correct? It is correct, wrongo, righto says. But why do you use product rule? It's a long way and you have lots of opportunities to make mistakes in this process. So let's go through the shortest method here. Okay, tell me how to do this. Now, what is the product rule? It is used when you have product of two functions, f of x times g of x. But in this case, you have e square times root x. E square is not a function, it's a constant, wrongo. So you have a constant times root of x. So why do you use product rule for this? Okay, so how can I do this question anyway? Now let me ask you one other question. What will you do for the function 3 root x? How will you differentiate 3 times root x? Oh, that's simple. I know how to answer this question. I'll write this as 3 times x to the power of half. I'll keep the 3 unchanged. I'll differentiate x to the power of half using power rule, and this is what I will get, 3 over 2 root x. Exactly. So it is a constant times root x. It's the same as e square root x, right? So you should keep the e square as it is. Don't change it. Square root x, differentiate it using the power rule, and then you will get dy dx to be equal to e square over 2 root x, which is the same answer you got using the product rule. But you can notice that how quickly you can do this using this power rule without making any mistakes. Yes, righto, as usual, you are always right. Okay, let's go to the next example. Find the derivative of 3 over x square. Come on, pause the video here and try to find the derivative of 3 over x square. What rule did you use? Of course, quotient rule, because something over something is quotient rule, right? And then you will take the numerator as 3u and the denominator as v, and then derivatives of u is u dash, which is 0, v dash is 2x. You know all these things, but again you can notice that I'm taking a constant as a function here, right? U is a constant, but let me proceed to answer the question using the formula, and using this formula I will get dy dx as negative 6 over x cube. And now Rongo knows it's a long process and Raito is going to give me a shorter process. Yes, I don't have to use quotient rule, but what else? What can I do for this question? What is quotient rule used for? It's used for division of two functions. The numerator should be a function, denominator should be a function. Rongo knows that the numerator was not a function after he started using the quotient rule, right? Okay, Raito, tell me how to do this now. 3 over x square. The numerator is not a function, it's a constant. So try to avoid using quotient rule in these cases. So what you should do now, you should consider 3 as a constant and write the function as 3 times 1 over x square. 1 over x square is x to the power of minus 2. So the function now is 3 times x to the power of minus 2. So differentiating x to the power of minus 2 using power rule, you will get negative 2 x to the power of minus 3, right? So differentiating this, 3 stays as it is because it's a coefficient. And differentiating x to the power of minus 2 x to the power of minus 3. So the answer would be negative 6 over x cube as you got using the quotient rule. But you can see how quick it is and there is very less opportunity to make mistakes in this case. So try to avoid quotient rule or product rule when one of the functions is a constant. And also for this function x square over 3. This also looks like a quotient rule question, but it is not. X square is a function but 3 is not a function. Therefore, take the 1 over 3 as the coefficient, write the function as 1 over 3 times x square, differentiate x square as 2x. So the answer for this will be 1 over 3 times 2x. So you should not be using quotient rule just because it looks like a quotient of functions, okay? Make a note of this. When one of the functions is a constant, do not use product or quotient rule. Okay, Raito, I'll take a note of this. Let's proceed to the next question. Find the derivative of sine of root x. Wow, that's a wonderful question. Pause the video here and find the derivative of this function sine of square root of x. You know that this is a composite function, right? Yes, I know it. So I will use chain rule. Yes, sure. There is no other way to do it. So f of g of x is sine of root of x. So you know what is f of x and what is g of x. Sine of x is f of x. Its derivative will be cos. Root of x is g of x, therefore its derivative is 1 over 2 root x. All these things we know already. So we are keeping this ready and we are going to apply this in the formula. Y dash is, which is dy dx, is derivative of f and multiplied by derivative of g, right? So derivative of f is cos x. I just found that. Derivative of g is 1 over 2 root x. Is this correct? No. This is not right. What's the mistake here? You have not found the mistake here, Rango? So let's see. What's the formula saying here? F dash of g of x. So where is g of x inside f dash of x? You just found f dash of x, which is cos x. But you have not written f dash of g of x. So this should be f dash of g of x should be cos of root x. Raito is here to tell you what is correct. So this part is the mistake that you have made here, Rango. Cos x is not correct. It should have been cos of root x. So your dy dx should have been cos of root x over 2 root x. Please do not cancel the root x there because the numerator root x is with cos. So you should not cancel the root x. The answer is cos of root x over 2 root x as a final answer for this question. Note here that when you are using chain rule, you might miss to put the g of x inside the derivative of f. Please be careful with this when you are using chain rule in your questions. I hope you enjoyed this video and you will not make these mistakes in your examinations anymore. Happy learning from Kanitika.com. All the best for your examinations. Please subscribe, like and share my videos with your friends and families. Thank you very much.